everyone to the summary lecture of week 7 of the course Climate Change and Extreme Events. In this week we have basically talked about the recent extreme events case studies. So, in this particular lecture we will discuss about in very concise way what we have covered so far in these particular week 7, and then towards the end of this particular lecture we will talk about what we can do as a hands-on exercise from the, or we can learn about how we can look at these extreme events time series and how we can infer from that particular data set that okay, this is how is the data set is telling, then how we can interpret what is the historical behavior of the extreme climatic events. So, we have talked about in this particular lecture, the previous lecture, first we have talked about the Uttarakhand floods, 2013 Uttarakhand floods, which was occurred between 14th and 17th June 2013. So, there were several areas were affected, for example, Kedarnath, Rudraprayag, Chamoli, Pithoragarh and Uttarkasi. And here we have also assessed post this effect that 5,700 people have been died and many casualties were reported. Many were basically suffered, injured because of this particular climate extreme events which happened in 2013. So, you can look at this particular picture we have discussed during the lecture as well, that this was a settlement in the Uttarakhand region, this Kedarnath valley, and we can see from this photograph that we can identify that there are lots of urban structures were built up over the period of time, and primarily these structures were very close to the river channel. So, as we have already discussed multiple times in the previous lectures, that if you are talking about a river, this is a river channel and there is a flood plains also associated with the river channel. When there is an extreme amount of floods or comes, that basically inundate the whole region, not including the river channel, but also the neighboring floodplain region as well. So, suppose when we are converting those floodplain region for urban settlement or some sort of construction or some sort of man-made structures, if we are planning to build there, if we have already built there, since the nature of this floodplains or river, those areas are basically to accommodate extra water, or basically during the floods they have been inundated, and therefore when any particular higher magnitude flood events comes, those areas are high risk or on high alert, because most of the excess water which is basically not accommodated within the river channel can go into that floodplain boundaries, and that basically the whole region will be submerged. So, that is basically a higher risk flood zones where any kind of construction if you are doing, that would be dangerous for human perspectives, socio-economic perspectives like that. So, here in this figure we can clearly see that a lot of structures were built up and which is primarily very close to the river channel. After the event we observed that whatever the structures were built up in that particular region has been significantly demolished or damaged by this basically river overflow conditions, because it was a very high flood in that particular region. So, the primary reason was to make this catastrophe a really significant one because of the unsustainable manner of the human construction near to the river channel. The another reasons for this particular floods, Uttarakhand floods, were intense and prolonged monsoon rainfall, and because of very intense and prolonged monsoon rainfall, we have observed that a cloud burst event occurred, a very high intense rainfall event, high magnitude rainfall event occurs in the upstream of the Kedarnath valley, and there was a lake situated there that has a limited capacity to store certain amount of water. When there is a cloud burst kind of event occurred there, the extra water also comes into that particular lake, and that has breached the lake boundary. When that particular lake boundary breached, a significant amount of the water which was stored earlier and which is also coming from the cloud burst flowing downstream near to the river of Kedarnath valley region, Mandakini river and all of the region were submerged in a very short period of time. And that is basically a lot of people were affected, a significant damage were reported, many buildings which were built very close to the river channel has been damaged, and that is basically we have observed from this particular flood event. Then in that lecture we have also talked about 2015 South Indian flood, which was also one of the biggest flood we have reported in the southern Indian region. It was occurred during during November and December 2015. There were many areas, Chennai, Kudalur, Kanchipuram, Tiruvallur and Puducherry were affected. It was also reported there are more than 500 people have been died, and primarily this is because of the heavy northeast monsoon rainfall, intense rainfall that provided a very extra water, and because of the region has been already saturated, a lot of water which we are received from the monsoon rainfall has been converted into surface runoff, and that basically created a lot of flood water or surface water, excess surface water in multiple places that basically created a flood hazard in that particular region during 2015. Primary reason is rainfall and monsoon, that was high intensity monsoon. And the another reason is basically this was a significant damage because of the encroachment of the water bodies. We have already reported multiple times that there were many water bodies or the lakes were there. Now it has been converted into land use land cover change or has been converted to some sort of different types of land use activities. When we convert these water bodies, these are also buffer, which basically a kind of an interaction zone of surface water and groundwater. When we close those buffer or when we close those region where a significant recharge can happen, the extra amount of water will flow, right? When it will flow, it will create flood water, it will create many other flood related disasters. So therefore, that is another region was water bodies which was encroached. There was a poor drainage system, and that has been created some sort of high duration, long duration water clogged situation in certain region that basically created massive problems. And then is another region because intense rainfall has been everywhere in that particular region. There were multiple reservoirs were also situated, and because of the excess water which was coming from the upstream region, from the higher elevation region, and it is going to that particular reservoir. So these reservoirs, dams has certain capacity. It can store certain capacity of water for not for very long period of time, because they have to also evacuate that water to the downstream region. So the release of, because intense rainfall was occurring, there was an encroachment in the water bodies, that is poor drainage system, and then there is a excess water which is coming from upstream region through the reservoirs, that also created more problems associated with the flooding in these particular region and created a significant damages. So particularly when we comparing these two different events, Uttarakhand, both the events we have observed a heavy rainfall, extreme rainfall region, rainfall that is basically monsoon and in the the basically northeast monsoon season. Then there is a cloud burst condition in Uttarakhand. There is a the human activities, reservoir operations, and also the influence of El Nino was also reported, and that is one of the reason that we have observed a significant flood events in that particular region of southern Indian part. And similarly, we have observed a significant damage caused by Uttarakhand flood in the Kedarnath Valley in 2013. What are the hydrological factors in the Uttarakhand? We have discussed that steep terrain which amplify the runoff, because when we have a steep terrain, Himalaya is very steep terrain, there we have, if the runoff is generated, it is possible that there will be a very higher velocity of rainfall flow, and that will go into the downstream part. If let us say we have huge amount of rainfall occurs in that particular region, it is possible that we have a very high velocity flood water wave which comes towards the downstream region, and that basically inundate the whole region in the low slope region like that. The melting of glaciers, increasing water discharge can also amplify this situation, because when we have early higher runoff component, that might saturate the ground little bit early, and when we have higher amount of rainfall, that create the flood events in those regions like that. In the southern Indian part, urbanization, reservoir operation, encroachment of water bodies, over reliance on the reservoirs, leading to mismanagement and all those factors works all together, and that basically we have seen the results of these two different catastrophic events. Then in the another lecture we have talked about drought event, particularly the millennium drought conditions in the Australian region. We have talked about a drought which was started in late 1996, and that was terminated in mid 2010. There were multiple regions in Australia, for example, southeastern Australian region, Victoria, New South Wales, and South Australian region were affected. And the primary reason behind this kind of the drought event was the longest and most severe droughts, and that is basically driven by very long period of time, a very low amount of rainfall in different parts of the country in the Australia like that. So if you can look at these images, that can also show that rainfall deficit region. So we have also seen that most of these regions, southwest and southeastern part of the basically the Australia is basically showing recorded very lowest amount of rainfall decline ranges, or let us say some region where here we have observed a very high range of the decline rainfall reported across. And then we can when we compare here also basically from different periods as well, 2001 to 2009. Here we can also see that this is the region where we have observed a slightly lesser but comparable to the previous pattern is like slightly lesser here, but overall comparable to the 1997 and 2009 conditions like that. So some part of the Australia is observed to be very highly decline of the rainfall pattern. Some part of the Australian region are also not very high, but yes, relatively lower amount of decline range of the. So what is the major factor behind this millennium drought condition in the Australian region was reduced rainfall due to ENSO event that was strengthened by subtropical ridge blocking precipitation, which blocked the significant amount of moisture transport from one place to the another place, and that is why it creates a very relatively drier conditions in certain parts of the region. Then another region is climate change, which basically exacerbates this temperature extremes, and that is basically also significantly affect the land and atmospheric coupling, and therefore we have also observed a significant drought anomaly because of these different patterns also. There is another region, for example, human induced factors we have also talked about, over extraction of the water resources and land use change impacting the water cycle. So, when we are talking about over extractions means, suppose we have meteorological drought conditions, which means the rainfall was relatively lowest or very low amount of rainfall we have received in that particular month or season, like that. But it can be offset by, let us say we have already some amount of water stored in surface water or reservoir or groundwater, like that. But suppose let us say we have already extracted a significant amount of water from surface water, reservoir or groundwater resources. If the meteorological droughts comes, it will very quickly convert to the hydrological drought, and then it can be agricultural and socio-economic drought conditions. Therefore, the management of water resources is very important when it is talking about, let us say, drought conditions. So, what is the essential difference between drought and flood? Flood occurs for few days and drought occurs for few months. It's a basically longer period phenomena compared to flood. So, therefore, we have to be very extra resilient upon the water resource management, water infrastructure, surface water management, over extraction of the water resources from the groundwater resources, because if in the emergency situation, if we do not have water in a certain region, it might exacerbate that particular problem in those regions, like that. So, the meteorological trends during this particular drought was rainfall deficiency, significant decrease in precipitations across affected areas, particularly this Murray and Darling Basin, where we have seen that below average inflow into this particular basin, and that is basically one of the reason for hydrological drought conditions in that particular region. Then we have also observed, because of the climate change, there is an increased evaporation rates due to rising temperature, and that also affect the water resource availability in that particular region, and that is one of the also further reason for this kind of intense drought event in that particular region, and record breaking heat waves during the drought period. So, in the beginning of when we talked about the heat waves, we have already discussed that, let us say if you change the land use land cover conditions in such a way that we are changing the albedo, we are also changing the sensible heat and latent heat behavior of those areas, and we are also, when the latent heat decreases and sensible heat increases in a certain region, the air which is closer to the ground become more drier, more hotter, and that basically creates more hotter condition in that particular regions, because we don't have the counterbalance process, which is basically evaporation or evapotranspiration, like that, the cooling effect. So, therefore, this is one of the further regions where we have observed a very significant drought conditions in that particular region. What was the impact on the water resource? We have already discussed that there were many reservoirs, in particular Australian region, where a significant decline of the stream flow was observed, and the reservoir level were significantly dropped, significantly affected. That reduced because of the river flows which affect the agricultural and ecosystem services. Major cities implemented the strict water restrictions because of the low availability of water, and the groundwater depletion were also became very there, because increased reliance on the groundwater levels to long term sustainability concerns in that particular time period, like that. So, this particular case study tells that how we can use the available sustainable solutions to mitigate the effect of drought, how we can promote the water resource management so that we can avoid those types of conditions, and how we can use that land use land cover information, or let us say climate extremes time series information, to tell us about let us say what is likely to be happen in that particular region if this kind of the conditions continues to be implemented or occurred in that particular regions, like that. So, that is basically we can learn from these case studies and all. Then in the next lecture we have talked about heat waves. Primarily we talked about the March and May 2022, the Indian heat wave condition in 2022 years. There were several regions were affected, for example, northern, central India, Rajasthan, Punjab, Delhi, Uttar Pradesh, Madhya Pradesh, Maharashtra. These are the states were affected. Almost a major proportion of the Indian subcontinent, Indian region were affected by these particular heat waves. There were several, temperature record has been broken in that particular year, particularly Delhi. We have seen the temperature was crossed 49.2 degrees centigrade. Rajasthan we have observed of above 48 degree temperature in that particular period. That essentially suggests a very hot event, a very heated event in that particular time period. What was the reason behind it, this heat waves? That is primarily driven by high pressure system. Persistent anticyclonic conditions prevent heat dissipation. It creates a sort of dome, and whatever the heats it is created because of albedo, GHG and all, it remains there for a very long period of time, and that basically creates some sort of positive feedback as well, and that basically heats up the whole region like that. Deficient pre-monsoon rainfall, that is another reason, because we do not have sufficient rainfall which occurred usually before monsoon period, and that is basically reduce the moisture level significantly and reduce the cooling effect. So, that is what in the previous slide I have described. When you have lower amount of surface water, subsurface water, or lower amount of evaporation, evapotranspiration kind of mechanism, it might create a more hotter environment because of the heat up of the air, because of the sensible heat. The amount of energy does not convert the matter into, let us say, water into vapor, and that remains there, that extra energy, and that basically heats up the whole the air masses near to the ground, that basically create a major problem. The another factor was westerly winds, which is basically transporting in hot and dry air from the desert region, and that also adds up to that particular problem, and that creates a very significant issues related to the heat waves. We have also observed the conditions of these heat waves during the night as well. So, that is basically created that hot dome conditions where we have GHG emissions, the positive feedback between longer radiations and with the interaction with different types of gases, clouds and all, that creates more positive feedback kind of situations in that particular regions. That is also create significant heat up or hotter conditions in the day and night situations like that. So, this is the climate change influences. When we are talking about these heat waves, we have observed that their frequencies, their durations of heat waves has been significantly increased. The role of greenhouse gases is very important because it contributes to extreme events. IPCC findings are also suggesting the projections indicate intensifying the heat waves in South Asia, including Indian region. There are multiple cities we have observed a significant rise in the temperature since 1901 to 2004 like that. What is the socio-economic effect of this heat waves? Are health effect, increased case of heat stroke, dehydration, mortality, vulnerability of elderly children and outdoor workers, agricultural losses. We have discussed about the reduced wheat and vegetable yields during that period of time, higher water demand for irrigation, power demand surges because of the increased heat conditions. We have increased electricity consumption for cooling, ACs and all, that leads to power outages in several states due to grid failure and grid states like that. That is also some sort of indirect effect caused by this kind of heat waves conditions in different parts of the world. So, in this particular week we have talked about 3 different major case studies. While discussing these 3 different major case studies. We have also talked about what is the major factors which were directly impacting these different extreme climatic events which is occurring in Uttarakhand or southern Indian region or Australian region or Indian heat wave conditions like that. Then we have also talked about what could be the particular steps we should have taken after this particular, or what is our learning after this case studies or these extreme events, so that we can prevent similar kind of the extreme situations in the future conditions, and we can provide a safer environment for different climate conditions like that. And then we have also discussed about multiple types of mitigation and socio-economic impacts as well. So based on overall these discussion, one thing is coming out to be very prominent, that when we have observed data set or observed trend data set, or let's say some sort of time series of climate extremes, we can do that analysis and we can look into that historical behavior of that data set, and then we can talk about how the extreme behavior has been changed over the time, whether the behavior of your time series is like the we have already observed during 1901, 1950s like that, it is continues to be the same pattern, or if you are looking at the pattern and you observe that since 1980s your climate extremes or whatever climate extremes you are taking, it is basically continuously rising since 1980s to till 2024 like that. So time series analysis is one of the key aspect area where you can give multiple answers to these questions, whether if you are taking about rainfall extremes or temperature extremes or heat stress or drought conditions or flood conditions. You can talk about what is the frequencies of let's say floods conditions in the different parts of the world. So the today's assignment is, in this particular lecture, in this particular week, you can read about time series analysis. What is exactly time series analysis, how you can implement it, what is the theoretical knowledge behind it. Time series analysis, you can, it's a very general topic, you can read any climate hands-on books or statistical books or hydrological books should provide a very general basic overview of this time series analysis part. You can read multiple statistical or data analysis books as well. And there is a concept called stationary and non-stationary. What is stationary? When you're talking about, let's say, climate extremes, there is a possibility that your data set is stationary throughout the time, it remains same. And the non-stationary is basically when your data set is changing over the time as well. So you can read about these concepts as well, and you can correlate with your whatever we have discussed so far in this week with that theoretical knowledge, and you can think about how you can implement this analysis for multiple different studies for your practice. So thank you so much for listening.